In today's video, we are going to simulate phonon dispersion relationship in one-dimensional lattice. According to Wikipedia, a phonon is the quantum mechanical description of an elementary vibrational motion in which a lattice of atoms or molecules uniformly oscillates at a single frequency. The meaning of dispersion relationship is the relationship between the angular frequency and Wavre vector of phonons. The Wavre vector or Wavre number equals to 2 pi over wavelength. The system will decide the angular frequency when the Wavre number is given. Before we start breaking down the codes, let's take a look on my simulation. We simulate the motion of phonons by simulating the motion of balls on springs since their motion is periodic and elastic. There are 50 balls in total and they are connected to each other by using 49 strings. They were all at rest at the beginning until we let the first ball on the left moves in syncurve motion. The first ball's motion will bring up the second ball's motion and third ball's and so on. All the balls and springs are moving on the x-axis and so do the wave. We have the simulation codes in both normal version and array version. In the array version, ball_pose is an array to keep the x-coordinates of balls. Ball_orig is an array to keep the position of balls when they are not in motion. Ball_v is an array to keep the velocity of the balls. Spring_len is an array to keep the displacement of spring from the rest position. At the beginning of the simulation which the balls are all at rests, the data kept in array ball_pose and array ball_orig are the same. The wave pattern of the ball's motions cannot be easily observed since they are moving along the x-axis. We create a black line above the balls and springs chain to observe the waveform, and this is how the wave looks like. If we connect the left side and right side of the spring by another springs, as we wave the connective spring, the wave will move from both end side of the spring to the middle. This is called periodic boundary condition. I have already explained some of the lines in this code in my previous video, so I will not repeat explaining them in this video. Most of the constants are given in my homework. The n represents the number of balls, which are 50 in total. The unit k is the unit vector of wave. In the for loop, we generate balls on springs by initializing their position, velocity and spring displacement. The position and original position of balls are generated using numpy while the ball's velocity is initialized as 0 and the spring length is initialized as 1. Speed over here is created to store the previous ball's velocity since we need it to do some conditional statements. In the while loop, lower t and upper t will be updated as dt increases. The first until the second last spring length equal to the position of second ball to the last ball minus the position of the first ball to the second last ball. The last spring length equal to the position of the first ball minus the position of the last ball plus n times d since they are connected by one connective spring. The velocities of balls are calculated in the same way as the springs. In the minor if loop, while the velocity of the second ball is less than 0 and the current velocity times previous velocity of the second ball is less than 0, the graph will be plotted. We have the Wavre number and angular frequency on the xy axis. The upper t will be initialized to 0 as the graph have plotted since we are considering each period of their motion separately instead of cumulatively. In the last line, we updated the velocity of the ball every time the while loop runs.